Hello, my name is Zach Coker, and I'll be demonstrating the program transformation add integer cast. I'll be using a file from the Samate test bench, specifically file CWE195 signed to unsigned conversion -malloc01.c. This file contains two functions. One is a bad function that demonstrates a vulnerability, and the other one is a good function that demonstrates a similar action that is successful. Here's the bad function. What happens is it has the variable data assigned a value of -1. This -1 passes the logic check to make sure that the variable size isn't too high. But then it uses an unsigned integer in the malloc function, where that value is converted to an unsigned value, which makes it a very large value that then tries to allocate extremely large memory chunk to the variable data buff. In the good function, data is assigned a value of 99, which passes the if statement and then allocates a data buff of size 99. Here's what happens when you run the function. The good function produces a printout of a lot of A's, while the bad function causes a segmentation fault. To fix this error, you can run add integer cast. To do that, you highlight the variable, you go to the refactor menu, scroll down, and select add integer cast. We'll preview the changes, so we click preview. And we can see that recommends two changes. The first one is it recommends casting data in the if statement to an unsigned integer type. This is determined using heuristics, and it's determined that the variable data was probably used in an unsigned integer context. It also recommends casting the variable data to an unsigned int in the malloc call. This cast doesn't do anything because it's already going to be implicitly cast to an unsigned integer type, but it makes the developer aware that cast is occurring, and so they're more aware of possible type mismatches. In this case, the if statement cast is the one that actually removes the error, but the malloc cast would possibly notify the developer that an error occurred if the if statement cast did not occur. Since we like the changes, we click OK. We can see that changes it in the source file. Now that the error is fixed, we can run the program again to see the changes it made. The good function still printed out all the A's, and the bad function did not produce a segmentation fault. This is because the negative value was converted to an unsigned int, which did not pass the if statement anymore, so the bad malloc was not executed.